Alright, we are going to start graphing these log functions. Graphing logarithmic functions. So I'm going to put an example here. F of x equals, let's do the log base 3 of x plus 4 minus 2. Right. Now, you're going to start with the parent exponential that would correspond with this base. So this is a base of 3. So what I would like you to start with would be y equals 3 to the x. And I would like you to make a table for that. And the same style as we've been doing. -2 to +2 for your inputs. And that would give you 1/9, 1/3, 1, 3, and 9. Now, we discussed in the last lesson about what a logarithm is. It's the inverse of an exponential. And back when we did the definition of inverses, you should remember that all we did was switch the domain with the range. So if I switch the domain with the range, I would get the inverse function, which would be the log base 3 of x. Okay? And you're not actually substituting anything into this. You're just simply reversing the ordered pairs from the last table. So this would now be 1/9 here, 1/3, 1, 3, and 9. And over here, -2, -1, 0, 1, and 2. Now, the next step kind of has the same feeling as what we did when we graphed exponentials. You have to look at the action of the graph translation theorem. This +4 in here is telling you are going left 4 units. And this -2 is telling you that you are going down 2 units. And then we look at this and kind of place it where it belongs in the table. The left action corresponds with the x column. So going left 4 would be subtracting 4. And then moving down 2 for the y column would be subtracting 2 there. Right? And now this will give us our final table. And this final table is the one that we're going to graph. So if I subtract 4, this would be -3 and 8/9. This would be -3 and 2/3. -3, -1 and 5. All right, on the right side, subtracting 2, this would be -4, -3, -2, -1, 0. So this is what we're going to graph. So I'm going to make a graph. I'm going to go up to, let's just say 7 units. Sorry, that's not perfectly straight. And if you remember back when we did the exponentials, those graphs had an asymptote, right? These will actually have an asymptote, but instead of the asymptote being a horizontal line, I'll just kind of put here as a recall, okay? Exponential had a horizontal asymptote. The logarithmic functions will have a vertical asymptote. Okay, and that vertical asymptote, it will correspond with the lateral movement, left and right movement. So a parent log would have the y-axis as its asymptote, and now we are moving that left 4 units. So my asymptote is going to be here at the line x equals negative 4. Right, and then I can now plot these other points, and you'll see they kind of hug that asymptote. Negative 3 and 8/9, negative 4. Be right about here. Negative 3 and 2/3, negative 3. Negative 3, negative 2. Negative 1, negative 1. 5, 0. And then we connect them. So these have this type of a shape. And it's now the function, as it's moving to the left, it's going and it's approaching the asymptote and moving downward towards negative infinity on the y-axis. Let's do another one. Oh wait, we forgot. Domain, range, asymptote. Well, the asymptote we already declared, x equals negative 4. Now, when we did all the other exponential functions, the domain was all reals. That flips around. Remember, when you take an inverse, you flip the domain and the range. So now it's the range for these types of functions are all reals. The domain, if you look at the graph, the x's only exist to the right of negative 4. So x is greater than negative 4 is your domain. So let's do another one. Now, for this one, I'm going to put in a compression. So if you remember back when we did the exponentials, where we had numbers out in front of the exponential that created reflections, or just compressions in general. Let's do f of x equals, let's do negative 2 times, let's do log base 1/2 of x plus 5, and we'll do minus 1. Okay, so this has everything again. It has lateral movement, it has vertical movement, and it has now this negative 2 in front as its compression factor. So we're going to start same way. You're going to have the parent exponential that corresponds with this base. So 1/2 is the base, so you're going to make a table for y equals 1/2 to the x. Again, I want you to use 5 points. Substitute in negative 2 to 2. And coming out, you would have 4, 2, 1, 1/2, 1/4. You're then going to get the inverse of that. That will then become the log base 1/2 of x, that table. And that is just switching the x and the y columns. And now we look at the function itself that was given and find the actions that are involved. So we have this plus 5 here. That is going to be left 5. We have this minus 1. That's a down 1. And we also have this compression of negative 2. So in the x column, all we have is to worry about is that left 5. So that would be subtract 5 from all of these. And then in the right column, you're going to multiply by negative 2. And then, moving down 1, then subtract 1. All right, so this will give you the third table, the final table. This last table is always the one that you graph. So if I subtract 5 from all these, let's see, that's negative 1, negative 3, negative 4, negative 4.5, negative 4 3/4. Now this, you have to do it in this order, just like we spoke about when we did exponentials. So you have to do the multiplication by the compression factor first, then do the up-down movement, whatever's happening in that particular problem. So negative 2 times negative 2 is 4, and then 4 minus 1 is 3. And then the next one, negative 1 times negative 2 is 2, 2 minus 1 is 1, and so on through the table. And it looks like we can get away with making a graph just going up to 5 units in each direction. So we'll do that. Again, sorry, this is not the straightest, but it'll do. So I like to, again, put my asymptote on the graph first. So the asymptote for these, and I'll just make a little space here, because we'll have to do it at the end anyway. Right, the asymptote corresponds with the horizontal change for these types of functions. So since I'm going left 5, the asymptote will be x equals negative 5. And I'll put that on there right now. And I'll start plotting the points. Negative 1, 3. Negative 3, 1. Negative 4, negative 1. Negative 4.5, negative 3. And negative 4 3/4, negative 5. And we'll sketch that. And the range is all reals. The domain here, the function exists, the graph to the right of negative 5, so x is greater than negative 5. All right, and now I'm going to list one more problem, and then you are going to try it. You're going to pause the video, and you're going to try it, and then I'm going to go over it. So let's do the log base 1/3 of x plus, let's do x minus 2. And let's do plus 4. Okay, so pause it here, see if you can do it, and then I'm going to go over it. All right, so the parent exponential, y equals 1/3 to the x. I make a table. Negative 2 through positive 2 gets substituted in. I get back 9, 3, 1, 1/3, 1/9. I then switch the table around for its inverse, which would be the log base 1/3 of x. So 9, 3, 1, 1/3, 1/9. Here, negative 2, negative 1, 0, 1, 2. Last step, graph translation theorem. This minus 2 in here is a right 2 movement. The plus 4 is an up 4 movement. So the right 2 means I'm adding 2 to the x values. The up 4 means I'm adding 4 to the y values. So adding 2 to these, 11, 5, 3, 2 and 1/3, 2 and 1/9. Adding 4 to these, that will be 2, 3, 4, 5, 6. So I guess we could make it go up to 11. Why not? Not that far off. Again, if you have graph paper, that probably would be a better choice to use. And we're just making do. All right, so this is the table. 11.2 is here. I almost forgot to put my asymptote. I always like putting that asymptote on first. So right 2 would be x equals 2. So it should be right in here. I mean, it doesn't matter. You can put it on at the end, but you need to put it on the graph. It has to be there. So 11.2, 5, 3, 3, 4, 2 1/3, comma 5, 2 1/9, comma 6. So you can see this is, getting real close to the asymptote. Remember, just like exponentials, this thing looks like it's going up and going vertical, but it isn't. It's never strictly vertical. It's pushing in from this side towards the asymptote very slowly as you move up on the graph. This side of the graph will eventually cross through the x-axis. Domain, range, asymptote. We already have the asymptote x equals 2. The graph is existing to the right of that, so x is greater than 2. And the range for all of these log functions are all reals. So that should be enough to get you through the assignment on graphing log functions.